Okay, so oxidation numbers of anything. Oxidation numbers are like little charges. They're basically telling you where the electrons are going, which one's gaining or losing. Well, let's look at something by itself. What is the oxidation number of just hydrogen by itself? Not bonded to anything, didn't do a reaction, just hanging out. It's 0. So anything by itself has a charge of 0. All right? A piece of copper sitting on the ground has a charge of 0. O2 floating around in the sky, not doing anything, not reacting with anything, charge is 0. Anything by itself is 0. Now watch what happens when you put them in a compound. Okay, if you put them in a compound like this, H2O, now they have charges. Now because they had to give and gain electrons in order to make a compound. They had to move electrons, right? So what happens is oxygen will normally form a -2 charge, and hydrogen will normally form a +1. I have 2 of those, so that's +2 for all the hydrogens. And look what happens. They cancel each other out. See how that works? Yeah? Okay. Let's put copper and oxide together. Let's put copper and oxide together. Well, now oxygen's in a compound. What's my rule say? In a compound, oxygen forms -2. That means this copper has got to be +2. Look at that. They cancel each other out. They make 0. Right? You overwhelmed there, Mr. Lamarion? So the ones you know for sure, people, the ones you know for sure, okay? Group 1, they'll always form +1s in compounds. Group 2 elements, they'll always form +2s. Oxygen, pretty much always, will form -2s. Fluorines or fluoride will form -1. +1, +2, -2, -1. And if it's by itself, not inside of a compound, what is it? 0. Group 1's +1, that includes hydrogen. Group 2 +2, oxygen -2, fluorine -1. By itself, 0. By itself, 0. Okay, so you're going to use those rules to figure out the numbers, the little charges. All right? Okay.